Okay, we're going to take a look at the exit slip from last time, exit slip 16. This was a review of the sum and difference identities. So problem 2 had actually been done in class, so we'll review just problem number 1. And then the third problem will actually be something you can do after class ends today. So to refresh briefly, the sum and difference identities allow us to take an angle that's not going to look super familiar, so in this case 345 degrees, and break it into two angles we do know about from the unit circle. So the sum identity for cosine says if you have cosine of a plus b, this can be broken down into cosine of the first angle times cosine of the second angle subtracted by sine of the first angle times sine of the second angle. And we don't have to have these memorized, they're on our identities handout, but we do just need to know how to use them. So in this context, we're working with degrees rather than radians. Last week we saw both contexts. So we just need to take 345 and split it into two angles that we do know about. There are multiple correct ways to do this, so whatever comes to mind is probably good. Maybe right now I'm going to use 45 plus 300 because I know those are two unit circle angles, and of course the sum of 45 and 300 is 345. So let's try using that as our way to rewrite cosine of 345. So we're going to say that cosine of 345 degrees is the same as cosine of 45 degrees plus 300 degrees, and the order here doesn't matter. I just generally put the smaller angle first, but again, that's just personal preference. And so this will be equal, using the sum identity, to cosine at 45 degrees times cosine at 300 degrees minus sine of 45 degrees times sine at 300 degrees. So this is a great place to just grab your unit circle and look up these angles. Of course, remembering that cosine is the x-coordinate of our unit circle ordered pairs and sine is the y-coordinate. So maybe just to make this process feel a little smoother, I'm going to flip over to the part of the unit circle that matters. So let's see, 45 degrees will be in quadrant 1, 300 degrees will be in quadrant 2. Let's talk about that 45 degree angle for a moment. So at 45 degrees, we can see that the cosine value is going to be square root 2 over 2, because that's the x-coordinate, and the sine value will also be square root 2 over 2. Since at 45 degrees, the x and the y coordinates are the same. Let's just take that much back to our problem. So that means when I see cosine of 45, I'm going to insert square root 2 over 2. I'll leave space for cosine of 300, which we'll grab in just a moment. And then when I see sine of 45, I'll swap that out for square root 2 over 2. That's what sine of 45 degrees is equal to. And we still need to talk about the sine value of 300 degrees. So far we just focused on the 45 degree angles. Let's go talk about those 300 degree angles now. So at 300 degrees, we can notice that the x-coordinate at 300 degrees is 1/2. That means that cosine at 300 degrees will be 1/2. And then sine at 300 degrees will be negative square root 3 over 2. So I'll just run back and put those in place. When we see cosine of 300 degrees, we can insert 1/2. And when we see sine of 300 degrees, we can insert negative square root 3 over 2. So let me go back to the unit circle and just highlight those one last time. So again, cosine was the x-coordinate of 1/2. Sine was the y-coordinate of negative square root 3 over 2. So last step is just to do a little bit of cleanup. It's typical to write these problems as a single fraction because notice both pieces that we're about to clean up have a denominator of 4. So the first fraction contributes a square root 2 to the beginning of the numerator, and the second fraction we've got a negative square root 2 times a negative square root 3, which will be positive square root 6. So this means that cosine of 345 degrees is exactly equal to the square root of 2 plus the square root of 6, all divided by 4. And so that's what it means to find the exact value. As a check, we can type in cosine 345 to our calculator, get a decimal approximation. And then we can also type square root 2 plus square root 6 over 4 and make sure those decimal approximations match. I'll go punch them into Desmos and just share a screenshot of that result real quick. Okay, so I did just go ahead and type it into Desmos, in degree mode. So cosine of 345 came back as roughly 0.97. Typing in the exact value we found of square root 2 plus square root 6 divided by 4, we get that same approximate 0.97 value. So that's a nice way to know that we've done good work with using the sum and difference identities. Hopefully that makes some sense, and we're going to move into some new material now. So get ready.